Okay, hi guys. So I'm going to start with the mole concept. So now I'm going to explain to you what does it mean to have a mole of something. Okay, so a mole is an SI unit. Okay, that stands for Standard International Unit for the amount of a substance. All right, so this is a fixed amount that everybody in the world uses. It is a fixed amount of particles. 1 mole contains Avogadro's number of particles. Okay, so Avogadro was a scientist and he decided or discovered that he put 1 mole and it equals a certain number of particles. It doesn't have to be particles, actually. It can be anything. All right, so I want you to think about, if I talk about a dozen of something, a dozen, there's that movie called The Dirty Dozen, and that's cowboys. So there's 12 cowboys. There's dozen eggs. So it's 12 eggs. There's a dozen bread rolls. So there are 12 bread rolls. Okay, so the word 1 dozen refers to 12 of something. Okay, so like 1 dozen eggs will equal 12 eggs. Okay, and here I'm showing you 12 eggs. All right, so a mole, 1 mole is 6,02 times 10 to the 23. So that is, if I was to write this out, and the comma would have to move 23 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It's that many of anything. Okay. Now there's not even that many grains of sand on the earth. Okay. It's a huge number. Okay. And it's written as scientific notation, 6,02 times 10 to the 23. You don't have to learn it off by heart, but you do have to know it. It will be on your data sheet. Okay, so it's 602 and a whole string of zeros, number of something. And that number of something equals 1 mole. Now, sometimes we abbreviate it by leaving the E off. So you'll see that around as well, like here. Okay, I didn't make a mistake. I really just left the E off. Okay, so like I say, 1 dozen is 12 of something. 1 mole is this number of something. And it could be anything, but we talk about particles because think about just on that little dot that I drew there. And you can't even see it. I drew a dot there. Now, you can imagine how many atoms are on that dot. There are loads and loads and loads and loads and loads of atoms on that dot. And can you imagine the number you would have to use to write how many atoms? So what they've done is that they've used this value, and they can say, well, there's 1.5 moles on that dot instead of one massive number. And as long as we know that 1 mole is equal to that amount of atoms or particles or ions or electrons or anything. It's exactly like I said a dozen is. You can have a dozen bread rolls, a dozen people. That means 12. 1 mole of something means that many of that. So I've tried to draw it, and I could sit here for the rest of my life, girls, and draw a 0, and I'll never draw that many dots. Okay, that many zeros. I'll never. Let me say that again. I'll never, if I had to draw a dot for every number, for a dot to represent this number, I would literally sit forever. Well, I could do this for the rest of my life, let me say, and I'll never reach that value. Okay, that's how big it is. Okay, but we use it because atoms are so small, and yeah, we can do that. All right, so let's see what happens here. So how many atoms of iron in 4 moles of solid iron? Well, we have 4 moles. So imagine I told you you've got 4 dozen eggs. How many eggs are those? That's the same thing. So it would be 4 times the number of particles, 6,02 times 10 to the 23. Okay, get my calculator here today. Okay, 4 times 6.02. Please use this button for your scientific notation. Times 10 to the 23. Again, you don't need to put to the exponent. It all works in one button. Okay, times, oh wait, sorry, I've already times it by 4. And I get 2,408 times 10 to the 24. And what did I ask for? Atoms. So we don't have a unit, but we do have to say what it is that we have got. So I asked you how many atoms, therefore it is atoms. How many molecules are in 3.2 moles of water? Okay, so again, I'm going to ask about molecules, and water is a molecule. All right, so excuse me, I've got the number of moles, and just like the dozen, I times it by Avogadro's number. Okay, this sounds easy enough, okay, but when you're in an exam and I ask you these things, you can panic and not know what to do. So you've got to have your wits about you. Water is a molecule, and so I'm asking, there are 3.2 moles of water molecules. How many water molecules are there? Okay, so we times the number of moles by Avogadro's number, and we get 3.2 times 0.02 to the 23. Okay, and I'll end up with 1,9. Now, when it is like this, so let me show you here. I don't know if you can see it. It's 1.926. We normally round off to 2 decimal places, so that will become 93 times 10 to the 24, and it is molecules that I'm looking for. Okay, how many ions? So now I'm asking about ions, charged particles, are in 45 moles of salt. Okay, now be careful here, because salt is made up of 2 types of ions. We have a positive ion and a negative ion. Okay, so I'm going to say, all right, I know I have 45 moles of positive and negative. So this is one whole thing. Okay, so I've got 45 moles of a salt that is made up of that. Okay, so 45 times 6,02 times 10 to the power of 23, and I get 45 times 0.02 times 10 to the 23, and I get 2,71 times 10 to the 25. Okay, but now that is not ions. That is just those together, because salt is made up of an Na and a Cl, and they are both ions. Okay, so I know that all of these particles, 1 plus 1 minus, contains 2 ions, 1 plus 1 minus. So if I times by 2, I get how many complete ions? So 5,42 times 10 to the 25. All right, so let me just talk this through again with you. So I asked for salt. Okay, if I asked you for anions only, that means that there's only one type of negative anion in salt. But because I asked ions, it could be positive or negative. They are both ions. And salt is made up of one of each, Na and Cl. So what I did was I first worked out how many of those components, a component that is made up of one each. Okay, I then times by 2, because that one component is made up of 2 ions, and that gives me that. And so there are so many ions in 45 moles of salt. Okay, so we do have a formula, okay, and the formula is N, and it's also a very weird formula, but you'll get so used to it and so, what's the word, familiar with it, that you won't even think about this anymore. So N stands for number of moles, okay? So the N is your number of moles. Your small letter M is the mass of a substance. So I have this pen and the mass of this pen is 20 grams. Okay, that is that M. The capital M is the molar mass. And you will never get the molar mass because you can calculate it by using the periodic table like you did in the previous pages. Okay, so calculating the number of moles by using the mole equation. This is the mole equation. So the first thing you do is calculate the molar mass. Okay, you substitute the mass in the molar mass and you use moles as the SI unit. Okay, so here we have how many moles in 43 grams of ammonium chloride. So that means I have on a watch glass, I have a bunch of the crystal sodium chloride, and I have measured it, and it measured, I weighed it, and I got the mass of 43 grams. Okay, and so we go, cool, I have that. Now, interesting enough, is that in chemistry, the SI unit for mass is grams. And you remember in physics, the SI unit is kilograms. So grams are perfectly fine here. Always just think about chemistry is about the small stuff, like atoms, and physics is like the big stuff, like cars and velocities and stuff. And so you need a small unit for mass in chemistry. Right, so the molar mass. Now take a look. I don't know if you can see. I'm going to maybe try and lower this so it's a bit bigger. So have a look here. This is a molar mass, so it's capital M. And then as a little subscript, I've put NH4Cl, which is the formula for that. This immediately tells me, or tells anybody, that I'm working out the molar mass for ammonium chloride. There's nitrogen at 14, 4 hydrogens, and 1 chlorine, and I get a molar mass of 53.5 grams per mole. Okay, I have the mass, the small m of 43 grams. I then put it in. Sorry, this is not done nicely. I mean, normally you would do that. I think when I did this, I was a bit lazy with using the equations app or part on the Word document. Okay, so you would set it out like this. Put your formula, you get a mark for your formula, a mark for your correct substitution, and those are your number of moles. Now you can have a fraction of a mole because it's like saying what is a quarter of a dozen. Okay, so if you say a quarter of a dozen, that's a quarter of 12. Okay, and that is 3. Am I right? Yes, 3 times 4 gives you 12. So a quarter of a dozen is 3. So this is a fraction of a mole. So 0.8 of a mole. And you can then work out, oh, that's so many particles. Okay. Right, so here we have a whole load of examples. I think I'm going to do 1 or 2 with you, and then I'll maybe look at these where you do some conversions. So the first one should be fine for you to do. So the second one is 50 kilograms of zinc sulfate. So let's just figure out the formula for zinc sulfate. So we know it's ZnSO4. Let's just see if this is the right formula. So zinc is 2 plus, sulfate is 2 minus. Yes, they're a 1-to-1 ratio, so that's what it looks like. Okay, let's get a molar mass for ZnSO4. Okay. That would be, oh gosh, my computer's off. I need a periodic table. Okay, so we need zinc. So let me just do this. So I know to put zinc there. And then we're going to have 4 oxygens, which is 16. I think sulfur is at 32. I can't think. Okay, I'm waiting for my computer to switch on. Okay, but anyway, in the meantime, now let's go with our mass. our mass is equal to 50 kilograms. Now remember, the K in kilograms stands for 1,000. So it's 50,000 grams. So instead of using the letter K, you can say 1,000 or put 3 zeros. Okay. Or you can put times 10 to the 3, which I know some of you don't really like the things. Okay. So that would be equal to 50,000 grams. All right. And there we go. So we will then, let me just put in my password. Okay, right. Let's hope my periodic table is still, yes, it is still, yeah. Okay. Okay, so the formula is mass over molar mass. Come on. Right. And we get the mass of 50,000. Okay, my periodic table is up and running. So zinc is 65,4 and sulfur is 32. Okay, so let's work that out. So 65.4 plus 32 plus 4 times 16. And that gives us 161.4 grams per mole. Right, so 161.4 grams per mole. And that is 50,000, 1, 2, 3, divided by 0.4. And that is, number of moles is 309.80 moles. Okay, so that's a lot. I mean, imagine, 1 mole is that big number, 6.02 times 10 to the 23. But now you have 309.8 of that. Sure, that's quite big. Okay, so over here, remember, this is grams, no problem. Remember, I don't know if I've done this with you yet, but this is a microgram. Okay, and it's a Greek letter mu. Okay, it's called mu. And what it means is times 10 to the minus 6. All right, so this would be 5. And instead of putting the letter mu, you put times 10 to the minus 6. Okay, all the time. Always, 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 always. Okay, so that's how you know you can do that. All right, so that is your mass, your molar mass, magnesium nitrate. Let's just draw it here. We'll write it here. Magnesium NO3. Let's see if we need to balance. Magnesium is +2. Nitrate is -1. So we need 2 of those. Okay, so this is quite a big one. So my magnesium, so MgNO3 2. Magnesium, I've lost magnesium. I'm looking in the complete wrong place. 24,3 plus, now I'm going to put this in brackets, nitrogen is 14 plus 3 oxygens, which are 16, and there we go. Okay, so 24.3 plus 2, 14 plus 3, 16. Okay, and we get 148,3. Again, you write down your formula, and then your mass is 5 times 10 to the minus 6. Your molar mass is 148,3. You divide the 2 and you get how many moles you have of magnesium nitrate in 5 micrograms. I know I said it's mu, but that's just the name of the symbol. But this is actually micrograms. That's what do we say? Okay, micrograms. Okay, let's just get this answer quickly. Divided by 148.3. Okay, and I get 3,37 times 10 to the minus 8. moles. All right, so there we go. There we have it. So it's a very, very small fraction of that very, very big number. Okay, so you have think tank 2 to do. Please let me know if you're not coping with this. What I'll do is I'll give you a few minutes and then I'll post these answers so that you know you're on the right track. Okay, so you've got 1, 3, and 4 to do for me. Please follow the instructions. You just have to follow the instructions. Don't worry too much if you got a bit confused here. I will be going through this type of question again. All right, I hope you have a good day. Cheers for now.